we talked about the intimate relationships between arrays and for loops. So intimate, right? And let's do an example here just real quickly. I want to show you two ways to use a for loop to grow through arrays because it's important and it'll make life so much easier for you. Okay. Oh, sorry. You're not supposed to do that. There we go. Don't specify it over here, specify it over here. This is a reference to any array, and this is the actual array it's referencing, the literal array. But it can reference a different array the next second by just saying x equals new int 32 will reference a new array. If I put that down here, x equals new int 32, now x is referencing a different array, and so it doesn't make sense to put a number in there. Okay, so that's why it screams at you when you try that. All right, so we have x as an array, and we talked about this, but where do we start? Right, where might we end? Okay, and we were doing something like, I don't know what we were doing. Something like, we were putting some number in it, right? Equals 100. All right, cool. So all these 15 boxes are going to have the value 100 in. I guess we were putting 15 in 100 boxes. Doesn't matter. All right, very cool. There's another way. So this happens so often with arrays because they have such a relationship, right? That there's another way Java and other programming languages have come up with iterating through for loops. And it's the preferred way, iterating through arrays using a for loop. And it's actually the preferred way to use it. So we do this just so that you have a good understanding of for loops. But if here on out you want to use the easier way of doing it, feel free to do that. And it's called the for each, okay? And it was added to the Java standard later after other programming languages were like, for each is where it's at, and Java's like, yeah, I guess for each is where it's at. So I gotta remember how to do it. I might have to look it up because in Java it's different than, in other languages it's like for each. You actually just use the word for each. Here I believe it's like okay, I'm gonna try something out. I think that worked, unless that's a red underline. Does it just say unused? Okay, yeah, okay. So what you're gonna do, in fact, I don't even know if I have to specify this. I think I can go Y and out. Nope, it did not like that. Okay, so what you're gonna do is you're gonna say, so what this is saying is it's saying well, let's make sure it works first before I start explaining it to you like it's like I know what I'm doing. Okay. There we go. Let's see if that worked. Okay. So it did seem to work because it's system.out print line 100. Okay. So, and I'm going to put I in here just so that they're going to be different. So each bucket will have its own, it'll have 0 to 15 in it in each bucket. Okay. All right. Good. So what this is saying is it's saying the first time through the loop, I'm going to make Y whatever the contents of bucket 1 are. And the second time through the loop, I'm going to make Y whatever the contents, of bucket 0 are, right? The index 0. And the second time through the loop, I'm going to make Y whatever the contents. You know what? Actually, why don't we just why don't we use the debugger? Rather than me like explaining it like a lunatic. All right, so I hope you understand that this is going to put 0 in bucket 0, 1 in bucket 1, all the way to 14 in bucket 14, right? And I'm going to hit debug, and I set a breakpoint down here so it'll stop there so we can see what's going on. Actually, I want to show you a few things here. So one thing is, remember, we have our processing variables. One thing is we have x, and x has variables associated with it. Okay? It actually has 15 buckets, right? And each of these buckets has a value at it at this point. So it looks like we can already see that this worked as intended, right? In bucket 0, we have 0. And in bucket 1, we have 1. All the way down to bucket 14, we have 14. There should actually be a length. This isn't... There should be a length that says 15. I guess that's the length variable. But I don't know why it doesn't show it to you as an actual variable there, because it should be a member variable of x. Neither here nor there. In fact, if you do this to like ball, and we could do this to ball later, it will show you all the private variables of ball at that moment. So really, really helpful. We're stuck right here right now. So y hasn't come into existence here, because when we break, we're at the place before the execution of this code. But we can execute this code by hitting step, and it steps to the next line. Well, now y has come into existence, okay? And what y equals is 0, all right? Because that's what's in the first bucket of this. Actually, this is going to get confused. Well, it won't get confusing. And then y will equal 1, because that's what's in bucket number 1 of this. And then y will equal 2, because that's what's in bucket number 2 of this, right? So really, y is not equaling these indexes anymore. It's equaling these things, which happen to be the same value of the indexes. Let me do another example. I'm going to make this 15 plus, no, that's just going to confuse people. I'm going to make this I plus 1, okay? So in bucket 0, there's going to be 1. In bucket 1, there's going to be 2. And in bucket 14, there's going to be 15, right? So we're getting numbers from 1 to 15 in our buckets, okay? If I hit debug again, it will come to our breakpoint. If I hit down on X, we got 1, 2, 3, 4, 5, 6, 7, 8, all the way to 15, okay? If I step through this, the first time through the loop, y will be equal to 1, okay? And so I'm going to step, and y is equal to 1. You see it down there, right? If you have a magnifying glass. And then I step again, and 1 is printed out to the console. I step, y is equal to 2. You can see it down there. And I step again, and 2 is printed out to the console. I step, y equals 3, right? So it equals the contents of the bucket. I step again, and 3 is printed out to the console. What are the advantages of this? Well, they're pretty clear. We're never going to run off the end of the array. We don't have to deal with this dereferencing operation. That's what that's called. It's called dereferencing, where we actually have to say what is inside bucket 1. Because this pattern is used again and again and again and again in arrays. And so we decided to, or they decided it would be helpful to the programmer if we just said, hey, just go through all the buckets of the arrays and give me the contents, so we don't have to do this weird game that we've got accustomed to doing. And the languages listened, and so makes our life easier. We're less likely to run off the end of the array, right? We're not going to make a running off the end of the array error. But it's going in sequentially. Okay, so for each one of these, it's going in sequentially. If you don't want to go in up by 1, you have to mess with it, and I forget what those are, but you can look that up in the Java specifications. In Python, you can say step. Like, I want to go step, and I want to do every other one or something like that. And you can do that. And you can do start, I believe, and end and step and stuff like that. But then you're literally doing this. So there's not much difference. So for each though is super important. And so if you're gonna just cycle through these things, start getting used to for each, because it make your life easier. But do make sure you understand the regular for loop too, right? And go through the debugging if you want to understand that better. All right, see you next video.